Have you ever faced a situation where multiple async requests fire at almost the same time, and suddenly your app behaves unpredictably? Maybe a search box triggers dozens of API calls while a user types, or multiple buttons can start the same operation before the first one finishes. This can lead to wasted resources, race conditions, and bugs that are hard to reproduce. You might get stale data, duplicate work, or results arriving out of order, breaking your app's logic. Managing this manually can be tricky, especially when several operations run in parallel. That's where coalescing strategies come in. They help you control which requests actually matter, which results should be returned, and the order of execution. Let's see this problem visually. Here you can see 6 lorries running without any synchronization. In each group, I start 3 requests in a row, but each lorry moves at a different speed. Even though lorry 7 is started last, it doesn't finish last. The results arrive out of order. This is a classic async race problem. The last request you trigger is not the last one to complete. Here is the first solution, the use first strategy. I click start on all the lorries, numbers 1, 3, and 7 in both groups. However, in each group, only the lorry that started first actually moves. The others remain idle, and when the running lorry completes, its value is shared across the whole group. Everyone gets the same result, taken from the first request. Here's how the use first strategy works in pseudocode. We store the currently running task in the current task variable. If a task is already in progress, we simply return it. No new operation starts. If there's no running task, we start a new one and store it. All callers share the same task until it completes. Using the FlowSync library, you can achieve the same behavior with just a few lines of code by calling sync with use first coalescing sync strategy. Now let's look at when the use first strategy actually makes sense. First, when only the earliest request matters, for example, loading initial configuration. Second, when you want to dedupe rapid user clicks or repeated triggers. Third, when late requests shouldn't interrupt an operation that's already running. Fourth, when the underlying work is expensive and you don't want to run it multiple times. And finally, when consistency is more important than getting the absolute newest result. Now let's look at another solution, the use last strategy. Here again, I trigger all 3 lorries in each group. In the first group, I click 1, then 3, then 7. In the second group, I click 7, then 3, then 1. With this strategy, only the most recently started request is allowed to finish. Everything else is cancelled or ignored. So in the first group, the result comes from lorry 7, the last one I triggered. And in the second group, the result comes from lorry 1. So in both groups, despite the different click orders and different speeds, the final value always comes from the very last request that was started. Here's the core idea behind the use last strategy. Every time a new request starts, we cancel the previous one and mark this new task as the latest. Only that latest task is allowed to complete the shared task completion source. Any older task is ignored. The result, or the error, always comes from the newest request. And with FlowSync, the same behavior becomes a one-liner. FlowSync handles all the cancellation, result sharing, and task coordination for you. Let's take a look at situations where the use last strategy is especially useful. First, when an older async call is still running, but a newer one reflects the current state. You don't want stale results breaking consistency. Second, when user input changes quickly and only the latest value matters, like search, filters, or live previews. Third, when the back-end work is expensive and overlapping calls are pointless because each new request makes the previous one irrelevant. Let's take a look at the Debounce strategy, which builds on use last. The lorries do not start immediately. When a new request arrives, the system waits for a short quiet period. If another request comes in during that period, the timer resets and the previous request is dropped before it even starts. Only when the quiet period passes without new requests does the last lorry actually begin moving. If a new request appears while the last lorry is running, that running request is cancelled and the waiting period starts over. Similar to use last, all requests ultimately receive the result of the only lorry that completes. Here's how the debounce strategy works in code. We keep track of a running task and a debounce timer. Every time a new request arrives, we cancel any currently running task and reset the timer. Only when the timer completes without interruption do we start the last request. Its result is captured in a task completion source, so all callers get the same outcome. This ensures that rapid requests don't trigger multiple executions, and only the last one actually runs and returns its result. Here we move to the queue strategy, which is useful when you need to fully process every request sequentially. I click lorries 1, 3, 7 for the first resource, and almost immediately 7, 3, and 1 for the second resource. Each resource processes its own queue independently in order. So for the first resource, the final result is lorry 7. For the second resource, the final result is lorry 1. Let's look at the queue coalescing pseudocode. This is not production code, just the core idea. Each incoming request is added to a queue. If processing is not running, we start draining the queue sequentially. Every operation runs in strict order, one after another. We keep track of the last result while processing. When the queue becomes empty, we complete a shared task completion source with that last result. That means every caller waits, and everyone receives the final result of the queue batch. A new request after that starts a brand new batch. Here's where the queue strategy really shines. First, when strict ordering matters, every request is handled one by one, exactly in the order it arrived. Second, when side effects can't run in parallel. Think writing to a database or updating a shared file. Serialization avoids race conditions. Third, queue works like a spooler. Each job waits its turn, ensuring step-by-step execution without jumping ahead. And finally, when commands are idempotent, but order still matters. Event sourcing or workflow steps need consistent state transitions. In this video, we looked at a common problem developers face: multiple async requests running at the same time. This doesn't just waste resources, it creates race conditions and bugs that are notoriously difficult to reproduce. Coalescing solves this by adding order and predictability. Different strategies let you choose what matters most. Use first keeps only the first request and ignores later ones. Use last keeps only the newest request, canceling the previous ones. Debounce waits for input to pause, then runs a single final request. Queue runs every request one by one, like a spooler, and everyone gets the last result from the batch. Choosing the right strategy makes your async operations more reliable and easier to reason about. In the description below, you'll find a link to the FlowSync project repository. It contains the full source code, detailed documentation, and practical examples to help you implement these coalescing strategies in your own applications. Thank you for watching. Bye.